Hey, what's up, recalculus? I'd like to talk to you a little more today about horizontal asymptotes of rational functions. Let's think of the various ways a person could analyze a function for its horizontal asymptote. One way would be if the graph already exists, just look and say, and that would be pretty nice. Another way to determine the equation of a horizontal asymptote is by the brute force of computing a table of values as x approaches negative infinity and as x approaches positive infinity, and determining what y value the function seems to be closing in towards. And that is fine if you have a calculator and want to make a table like that every time. I don't want to do that. So I'd like to go back to the idea of rewriting a function in order to better see how it might behave at large, big old values of x. And we discovered a little trick here in number 2, that we can simply look at a function, a rational function, divide all of the terms by the highest power, and realize anything that still remains as a fraction approaches 0, and that leaves you to compare the ratio of what's left. So I'd like to do that 3 more times, and honestly, everybody, these will be the last 3 times we do this analysis, because after these next 3 examples are done, we are going to develop a rather awesome shortcut. But we got to put in the work first, okay? So let's look here at number 3, another rational function, 6x squared plus 5 over 3x squared minus 1, and the highest power I spy anywhere is x squared. Why don't we, once again, change the appearance of the function without actually changing what it's all about and what its graph would look like, and I'd like to divide every single term by x squared, and then simplify where I can. 6x squared over x squared works out very nicely to 6. 5 over x squared just doesn't. 3x squared over x squared is great, and 1 over x squared does not reduce. Okay. Lovely. Well, once again, think about the effect of dividing a nice number like 5 or 1 by something enormous when x is approaching positive and negative infinity. And that little tiny fraction there, in each case, will trend closer to 0, which means our overall fraction value trends closer to 6 divided by 3, or 2. We can jot down that idea using limit notation. I'm going to write the left and right limits at infinity in one statement because it's the same result either way. The limit as x approaches plus or minus infinity of f of x equals 6 over 3 or 2. And our conclusion there must be the horizontal asymptote is y equals 2. All right. We're going to look at that example later on after we do the next 2. Like I said, we're going to develop a great shortcut. Looking on to number 4, I look at every individual term, and again I see the highest power here, x squared. Beautiful. Do the same thing. We will change the appearance of the function in order to learn some information about it, but we're not actually changing what the function's all about. All right, so 6x over x squared, oh boy, that is still going to stay a fraction. 3x squared over x squared reduces all the way, and nothing else does. Oh no. All right, so we've got 3 terms that are all divided by various powers of x. As x gets closer to infinity, this guy, and this guy all approach their values get closer to 0. The 3 is just 3. It's not going to change. But what that does mean is our fraction goes closer and closer and closer to a value of, well, in the numerator, 0. In the denominator, 3. And dividing something like 0 by a number like 3 comes out to 0. What we understand from that, the limits of this function as x approaches positive and negative infinity do get closer to 0. The limit is 0. And the conclusion we then draw from that, we must have a horizontal asymptote at y equals 0. Bravo! All right, one more to look at, then we will take a step back and look at all of them together to learn the trend. So I look at each individual term, and again, the highest power is x squared, so I do the same adjustment I've now done many times in a row. We'll divide everything by x squared, and what we notice is we can reduce some of these fractions. All right, 6x squared over x squared, 6. 3 over x and 1 over x squared. Okay, that's about all that happens there. All right, we're getting pros at this. We know all of the little baby fractions there will get closer and closer and closer to 0, which means the overall fraction means, we've got like a number pretty close to 6 up high and a number pretty close to 0 down low. That is undefined, of course. And since there's no value for that division, there's no limit when we analyze plus and minus infinity that we can come up with. And that means there is no horizontal asymptote. All right, so you can't shake your asymptote for that one. So sorry, everybody, so sorry. But we will never do that again. 3 times in this video is enough. Thank you very much. What I'd like to point out, though, is in numbers 3, 4, and 5, I'd like to examine the highest power from the numerator and compare it to the highest power from the denominator. And let's really notice what's happening. In the first problem we did together, the highest power up high matches the highest power down low. I'm going to note that really, really quickly by saying numerator equals denominator, and I'm talking about degree when I make that statement. The degree of the numerator matches the degree of the denominator. So we had a tie of the powers. The horizontal asymptote was y equals 2. Funnily enough, of course, 2 happens to be 6 divided by 3. Okay. Let's look at the function we analyzed in number 4. The denominator has a higher power. Numerator less than denominator. And since the denominator has more, bigger, huger, faster growing powers of x than the numerator, when you increase the x values, the overall value of the fraction does get tinier, and you get a horizontal asymptote of 0. That's actually going to happen every time. And in our last one we analyzed, we had a numerator with a higher degree than the denominator. And that resulted in no horizontal asymptote. And, just think about numbers. You put bigger and bigger values in for x, squaring them makes the numerator way bigger than the denominator, and that will not give us an asymptote. So these trends here, everybody, they are so nicely summarized, and let's look at them at the top of the next page. So if we look at what I've written down, there are only 3 cases you need to know about for finding horizontal asymptotes. And those are the 3 cases we just lived through a moment or two ago. Matching degrees, the horizontal asymptote. Y equals, all right, I wrote LC over LC. What I mean by that is leading coefficient from the numerator divided by leading coefficient of the denominator. Just to shuffle papers for a moment here, that means I'm dividing the 6 by the 3. Yes, see? All right. When the denominator has a greater degree than the numerator, we saw that also, y equals 0. And when the numerator's degree is greater than the denominator's degree, no horizontal asymptote. 3 cases, only 3 cases. And from this point forward, I propose we use this little chart here of these 3 cases to come up with the asymptotes instead of doing all the other analysis that I've shown you up till this point. And this is so easy to use, everybody. I will kind of refer to this as the dummy chart. I don't think I'm calling you dumb. I'm just saying this chart is so easy, even a dummy could use it. You know what I mean? So please make sure that you mark this as important. You know where to find it until you can use this information without looking at the chart. For the last little bit here, could you try to use the dummy chart here and determine the asymptotes, the horizontal asymptotes for numbers 6, 7, and 8. I will pause the video. You do too. Work it out. Okay, welcome back. Let's take a look at how that went. For number 6, analyze the degrees. It is a tie. The top matches the bottom. I divide leading coefficients. 10 divided by 2 is 5. Boom! There's your asymptote. Looking at number 7, analyze the degrees. The numerator exceeds the denominator. 3 bigger than 2. No horizontal asymptote. And for number 8, we do have to figure out the leading term, x squared over x cubed, but now that we see that, boom, the denominator has the larger power. The horizontal asymptote is y equals 0. All right, that's it for now, everybody. Shake your asymptotes. Ta-ta!